Okay, let's dive into this explainer. Look, if you've ever built a mobile app, you've absolutely encountered it. Those dreaded, glaring blank areas when you're scrolling fast. Or maybe you've had to deal with an interface that just feels frustratingly laggy and unresponsive. Well, today we're going to fix those exact issues in your React Native applications by totally optimizing your FlatList configuration. We are using the official documentation as our guide to transform those sluggish lists into just buttery smooth, high-performance experiences. Here's our roadmap for today. We're going to cover Section 1, the anatomy of FlatList. Section 2, mastering viewports and windows. Section 3, tuning your FlatList props. Section 4, lightening your list items. And finally, Section 5, smart component rendering.
All right, Section 1, the anatomy of FlatList, or understanding the virtualized core.
So, to really fix these issues, we first have to look under the hood and understand the engine that makes a FlatList work without instantly crashing your app when you try to load, say, 10,000 items. The absolutely crucial point here is that FlatList is powered by something called VirtualizedList. This is basically React Native's take on the virtual list concept. What this means for you is that the list is actively, constantly managing its memory consumption. Instead of rendering your entire database of items all at once, which, would instantly crash your app, it only stores and renders what is absolutely necessary at any given millisecond.
But this creates a really delicate, constant trade-off, pushing for immediate responsiveness versus avoiding those blank areas. Think of it like a tug-of-war. If you touch a component and want it to respond instantly, you need processing power. But if the app uses up too much memory trying to be super responsive, it falls behind on the actual rendering. So when the virtualized list can't render your items fast enough to keep up with your user's thumb, you hit those frustrating blank, unrendered spaces.
Moving on to Section 2, mastering viewports and windows. Let's see the unseen.
Okay, we need to define the exact spatial zones where your list items actually live, render, and wait. First up, we have the viewport. The viewport is literally just what the user can physically see and interact with on their device at any given moment. It's the visible area of content that has actually been painted into pixels on the glass of their screen. Simple enough, right? The window, on the other hand, is a completely different beast. The window is generally way larger than the viewport. It's this invisible buffer zone extending above and below the physical screen. This is where your items are pre-mounted, basically sitting backstage, getting ready for the user's upcoming scrolls. Understanding this fundamental difference between what's strictly in the viewport and what's resting out in the wider window is absolutely key to mastering your list performance.
Next up, Section 3, tuning your FlatList props, which is basically our macro control panel.
You really got to think of these FlatList props as a giant mixing board. Every single dial you turn dynamically alters that delicate balance between rendering speed and memory limits. First up on our board is removeClippedSubviews. When you set this to true, which by the way is the default on Android, it automatically detaches views that are outside the viewport from the native view hierarchy. The pro here is massive. It saves precious main thread time and significantly reduces dropped frames. But you gotta be careful. The major con is that this can cause weird missing content bugs, especially on iOS, or if your list uses complex transforms and absolute positioning. Plus, it doesn't even completely deallocate memory, it literally just detaches the views.
And that brings us to a magic number, 10. That 10 is the default value for a vital prop called maxToRenderPerBatch. This setting determines the precise chunk of items built on every scroll. Now, if you crank this number above 10, the big pro is you'll see far fewer blank spots when scrolling because, well, your fill rate is higher. But the downside, more items per batch means longer, heavier blocks of JavaScript execution. And that can actually block other event processing, like a user trying to tap a button, which ultimately hurts your app's overall responsiveness.
Next up on the dial, we have 50. And in this case, we're talking 50 milliseconds on our virtual assembly line.
This dials in your updateCellsBatchingPeriod. While the previous prop told us how many items to render, this one dictates the delay in milliseconds between those batch renders. The huge pro is that by combining this with your batch size, you have total, complete control over your assembly line's frequency. But beware the cons here. If you render less frequently, you're going to create blank areas. But if you render too frequently, you're just going to jam up your processor and cause some serious, noticeable lag.
Okay, we're actually back to the number 10 again, but this time it's for controlling the absolute very first thing your user sees when they open your app.
This is your initialNumToRender prop. If you set this to a precise number of items that perfectly covers the exact screen size of your user's device, you guarantee an incredibly fast initial load. I mean, that is a huge performance boost right out of the gate. However, if you guess wrong and set this number too low, and it doesn't cover the full physical viewport, bam! Your user is going to be staring at awkward blank areas the very second the app opens.
All right, brace yourself for a big one. This next prop has a massive default value of 21.
We're talking about window size. Now to be clear, 21 doesn't mean 21 individual items. It's a measurement unit where 1 is equivalent to your total viewport height. So a default of 21 means the app is actively keeping 10 entire viewports of content mounted above the screen, 10 viewports below the screen, and 1 currently visible. The pro, it almost entirely eliminates the chance of ever seeing a blank space. The con, keeping 21 screens worth of content mounted takes a brutally heavy toll on your app's memory consumption.
Section 4. Lightening your list items. It's time to trim the microfat.
So we've optimized the container, right? But now, those individual list items absolutely have to go on a diet. The logic here is incredibly simple. The heavier your components are, the slower they're going to render. You've got to use basic light components. Honestly, this might mean having a tough negotiation with your design team. Tell them you need to avoid deep nesting, cut out heavy visual effects, and just generally reduce unnecessary interactions right there in the list itself. If there's complex information, don't jam it all into the list row. Move it to a dedicated item detail view so your list render times stay blistering fast.
And hey, another crucial tip for lightening the load: images. Every single image in your list is typically a brand new instance. The source docs strongly recommend utilizing community packages for this, like @d11/React Native Fast Image from Dream11. By using cached, highly optimized images, your visuals load significantly faster, which crucially frees up your JavaScript thread exponentially faster for other tasks. It's a real game changer.
Finally, Section 5, Smart Component Rendering. Let's look at some procedural optimizations. These are the literal procedural code tweaks you can make in your editor right now to physically stop your app from doing unnecessary math and rendering loops. The first incredibly powerful tool here is React.memo component. By wrapping your individual list items in a memoized component, you dictate exactly when they should update. You can actually pass a comparison function as a second argument to explicitly state, for instance, hey, only re-render this row if the title text actually changes. If your function returns true, the component just skips the re-render entirely, saving massive amounts of processing power when the user is simply scrolling by.
Next up, check your layouts. If all your list items have the exact same static height, you absolutely must provide the getItemLayout prop. Doing this completely bypasses the need for your FlatList to manage heavy asynchronous layout calculations. It's a massive optimization technique. Also, always make sure you're setting a key extractor or passing a key prop directly to your item to ensure React is safely tracking item reordering and caching.
So I want to leave you with a critical final check. Look at your render item function right now. Is it just an anonymous function sitting right there in your returned JSX? If it is, pull it out and wrap it in a use callback hook immediately so it isn't being recreated on every single render. You have the tools, you have the exact props to tune, and you know how to lighten the load. So ask yourself, are your list items doing way too much heavy lifting? Or are you ready to tune your FlatList for a perfectly smooth scroll? Fix these lists today, and then ask yourself, what other React Native bottlenecks are quietly draining your app's true potential? Thanks for joining me on this explainer, and happy coding.